So following on from the previous video, we were trying to work out the volume of this solid. Of this solid here. We are going to rotate it 360 along the y-axis. So when you rotate it, it will look something like this. Okay, and it will look something like this. So this is our solid here. Our aim is to work out this volume. So there were two ways of doing this. One was to sum up all the cylinders, which we've done in the previous video. So in this video, we're going to sum up all the washers. So we're gonna we're going to sum up all the washers. So in the previous video, when we did the cylinders, it gave us this answer here. So it was blah blah blah, and it gave us this answer here. So this video we're going to sum up all the washers. So in the previous video we summed up all the cylinders. So now we are going to sum up all the washers here. So to work out the volume here, we would sum up all the washers. So let's start from so we're going to sum it up like this. So from -1 to 0, to 0, and then don't forget, if you look at this here, if you rotate it 360, it will look something like this. Hang on, it will look something like this, and then this bit here, 360, it will look something like this. And it is this area that you're interested in. So you doing it the washer way rather than the cylinder way is actually a lot more complicated, because let's try and work it out. Hang on. So we are we're going to integrate it. So we're going to move it up like this. So from -1 to 0. So we're going to integrate it from -1 to 0, and then it's this distance, which is 1. So we need to work out we need to work out but basically you're going to get a washer looking like this. Okay, so this bit here would be 1. So the radius here would be from here to here, which would be 1. So it would be pi r squared. So it would be pi 1. The radius here from here all the way here is 1. Because of this, it would be this squared. So that would then give us the area of the big circle. Now we need to take away the area of the small circle. The area of the small circle would be this, from here to here. So looking at this, don't forget it is y. So as we're moving along here, as we're moving up, the y is changing all the time. Depending on where y is, we can extract the radius by looking at this. So y is moving about. So the radius would be the cube root of -y. So that would then give us the radius. Okay, so this would be this is the area of the big circle, which is this big bit. Take away pi, the radius of the small circle, which will be this thing here. Don't forget, it is y that's moving about. Okay, it is y that's moving about, and the radius would be this, minus y. Hang on, this, this, and then we got to square it. Okay, and then basically this bit here will be the area of the big circle. This bit here will be the area of the small circle here, and then you're integrating. Well, don't forget, as you're moving up here, the thickness of this thing here is dy. So you're integrating it with respect to dy. So just this bit here will be this. So don't forget so just that bit there would be this bit here. Okay. So you can see this method is a lot more complicated. And then hang on. So as you're summing up all the washers here, this bit here will be given by this. Will be given by this. Okay. And then you got to add it. So you got to sum up all the washers here. So summing up all the washers here would be so this here from -1 to 0 whatever dy here, and then we got to plus it with this bit here. So that would be from 0 to 1, from 0 to 1, and then blah 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 dy here. So you summing up all the washes here would be you doing this. Would be you doing this whole thing here. Okay, and then this bit here is really it's really complicated, this bit here, because we got to tidy this bit up. When you tidy this bit up, it actually becomes you can pretty much ignore the minus here, because hang on. So our aim here is to tidy up this bit here. So when you look at this here, you've got minus y, and then let's get this times this, so that will be 2 over 3. Okay. The point here is that you can ignore the minus, because well, this thing here you can imagine it as minus y squared, and then to the power of a third. You're allowed to do this. So yeah, you're allowed to do this. And then minus anything squared will be, well, when you got it squared here, you can pretty much ignore the minus. So even though you've got a minus stuck in here, because of this squared here, you can ignore that minus. So you can write it like this, because this bit here is really, you can think of it as being an even function. So it's an even thing. So you can ignore the minus, and then it will be this. And then you can merge these two, giving you y2 over 3. The point is that this is the same as this. Okay, so when you're here, tidy up, it will give you this. Okay, the rest is easy. Well, it should be straightforward. Okay, so the only complicated part is this bit here. You can tidy up to give you this. Okay. And then what? Hang on, let me think. And then integrate it. So integrate this, it will then give you this. Okay, so integrate this, it will then give you this. Integrate this, it will then give you this. And then hang on, let me think. And then blah blah blah. And then it will then give you this. Same as in the previous video. Okay, this method is a lot more complicated than summing up all the cylinders. Okay, yeah, okay.